Okay, kids, we're back here and section 3.1, practice question 3. Let me read it. The force of gravity on the heaviest person in history is 6.2 kN, kilonewtons, and the down arrow for down. So first thing is, oopsie, come on now. There we go. Is the fact that we know the force of gravity. And the force of gravity, now remember, force of gravity also goes by another name, weight. It's the same thing. Weight, force of gravity, same thing. And we know the equation for this. And we know, now it says 6.2 kilonewtons. That's 6,200 newtons. And it's got the down arrow, but we're going to let down be negative. Okay? It's just better like that. And we want to know the mass of this person, because mass and weight are different. Okay, hopefully you've seen that. There's some videos I asked you to watch. I talked about it in the video lesson. I hope you've done that. Okay, they're different. Now, there is one other thing we know, and we always know it when we're on the face of the earth. We know the gravitational field strength. This has a very specific name. Okay, this is about detail, not just, oh, that's G. G is gravity. No, it has a very specific name. The gravitational field strength near the surface of the earth. Look how specific I am. Look how long-winded it is. It's very specific. And we know it's negative 9.8 newtons per kilogram. Now, did we have G before? Yes, we did. Remember, it was negative 9.8 meters per second squared. That's when we were considering the acceleration due to this gravitational field. But this is the gravitational field itself. Analysis. Okay, we're going to use that equation right there. They want us to find mass. So we rearrange this equation. Right? We rearrange the equation to find mass. Mass is equal to this. Now listen to me carefully as I say this. Listen to me carefully as I say this. The mass is equal to the force of gravity on the object near Earth's surface divided by the gravitational field strength near Earth's surface. Because a lot of times students get lazy. Oh, it's gravity. Well, what's gravity? Force of gravity? Gravitational field strength? You don't fall into that trap. Be very specific and detailed in your language. I hope I'm making myself clear here. Hey, substitute, right? People complain to me, sir, you're using grass on such a simple short question. Yes. Okay? It's about making good habits. Keep that habit of organizing your thoughts in a structured solution. These are important, almost as important as the physics. Okay? So negative 6,200 newtons. It's a vector. It needs a direction divided by the gravitational field strength near the surface of the Earth. It's a vector. It needs a direction. And finally, solution. Now we substitute. Now that we've substituted, we can get our handy dandy, fancy dancy calculator out. So we're just going to write this as 633 kilograms because the unit for mass is kilograms. Okay. Now the textbook says 6.3 times 10 to the 2. Yeah, maybe we have one significant digit too many. It's possible. It probably is, right? I'm not going to take a mark off of that. Now, if you write down what the calculator said, 632.6530612. If you write that down, then you're totally ignoring the concept of significant digits. But if you're off by one, I'm not going to take any marks off. Okay, at least you're showing an effort. Okay, that's it for this one, kids.